Hey guys, welcome back to the channel. Welcome to part 2 of this 2016 BMAT Section 2 walkthrough. My name is Faraz, I'm a Cambridge medical student, and in this video I'm going to be showing you my solutions to questions 10 to 18 of this paper. Also, if you guys are studying the BMAT this year, I'd highly recommend checking out sigmamed.co.uk. Me and my friend Hamza have put together a video course for the BMAT that was used by over 80 students last year and that some students have described as the course that makes all the difference. It's honestly an absolute steal at just £30, and it is really worth it given how much we've included in it. But without further ado, here's part 2 of this BMAT 2016 full walkthrough. Okay, so here is part 2 of this walkthrough. Question number 10. Mohr salt is a common lab agent. Use the information of the most abundant isotopes below to calculate the formula mass MR of the hydrated salt. Formula of Mohr salt is NH42 FeSO42 6H2O. So let's start with the 6H2O. The mass of H2O is 2 times hydrogen, which is 2, plus 16, which is 18. So if we do 6 times 18, 6 times 10 is 60, 6 times 8 is 48. So this totals to 108. Now, the mass of iron is 56. The mass of SO4 is 32 plus 4 times 16. 4 times 16 is 64. 32 plus 64 is 96. So the mass of SO42 is going to be 96 times 2, which is 192. Let's add that too. And now we need to find the mass of NH42. The mass of NH4 is simply 18 because it's 14 plus 4 times 2 is 36. So now if we total these together, we are going to get 108 plus 192. I'm adding those together because it gives a nice 300. 56 plus 36 is 92. So the overall answer is going to be F, which is 392. One thing you want to keep in mind is you want to add the numbers that look nice. Since you see an 8 and a 2, that's going to add to a 10. It's going to give you a nice number. And you want to avoid doing a bit more difficult calculations, for example, like 108 plus 56. Make your life easy, please. And please try and be quick with the mental maths because you can waste so much time trying to add numbers together if you don't know what you're doing. And time's really precious in the BMAT. Okay. Now for question number 11. An AC voltage is induced in a coil of wire when it is rotated in the magnetic field. This voltage can be displayed on the screen of an instrument called an oscilloscope, which shows the variation of the induced voltage on the y-axis plotted against time on the x-axis. Oscilloscope trace is a result of rotating a coil at constant speed in a uniform magnetic field. Which one of the following traces would result from rotating the coil at a faster speed whilst keeping all other conditions unchanged? And the scales stay the same. So what we'd see is we'd see an increased amplitude as well as an increased frequency. So you'd get more peaks and troughs per unit time, i.e. it's going to be one of answer options B, D, or E. B is the only one where the frequency is increasing, so the correct answer option is going to be B. Okay. Simply put, it's because the coil is rotating more quickly, you're going to get bigger voltages induced, and the voltage is going to peak and trough more frequently since the coil is spinning more quickly. Okay. Question number 12. The diagram represents a circular cross-section of an artery with an external D of 1.6 centimeters. The thickness T of the artery wall is 1 millimeter. What is the internal cross-sectional area of the artery? So the area of a circle is going to be pi r squared. So we essentially want the area of the big circle minus the area of the small circle. Sorry, we essentially just want the area of the internal bit. So the overall radius here, r, is going to be half of 1.6 centimeters, which is 8 millimeters. And if we just subtract t, which is 1, it's just going to be pi times 7 squared, which is just equal to 49 pi millimeters squared, which is going to be answer option D. Again, you want to avoid making the mistake of finding the area of this bit, and that would be if you subtracted the big area minus the small area. We're just looking for the small area, so just pi times 7 millimeters squared, which is 49 pi millimeters squared. Again, use the answer options as a guide. It leaves it in pi, so don't try and approximate pi. If you guys want to learn a lot more about how to do these types of questions, as well as section 1 and section 3, how to write the perfect section 3 essay, the section 2 2022 full walkthrough, check out sigmamed.co.uk. Me and my friend Hamza have put together a £30 BMAT course that teaches you absolutely everything you need to know for the BMAT. It was used by more than 80 students last year, and students have described it as the course that made all the difference. Honestly, it's a real investment into your BMAT preparation, and I would highly recommend checking it out. Link is in description below. Okay, so now question 13. Which of the following molecules are involved in both aerobic and anaerobic respiration in a healthy human? Carbon dioxide, glucose, and lactic acid. So the only molecule involved in both aerobic and anaerobic respiration, since it's a substrate, is going to be glucose. So carbon dioxide is aerobic respiration, lactic acid is anaerobic only. So therefore the correct answer option is going to be B because it's 2 only. Okay. Now question number 14. Identify the correct products of electrolysis of the following electrolytes. Electrolyte being electrolyzed, aqueous calcium bromide. Product at the anode, bromine. Product at the cathode, calcium. That is wrong. B. Aqueous copper nitrate. Product at the anode, nitrogen. Product at the cathode, copper. Wrong. C. Aqueous potassium sulfate. Product at the anode, oxygen. Product at the cathode, hydrogen. That's correct. So the correct answer option is C. With electrolysis, it does come up fairly frequently. You kind of just need to know the products of common electrolysis experiments. This is just a case of memory. There's no real way to figure it out. You just need to know it, either from the Section 2 Assumed Knowledge Guide or your own GCSE/A-level chemistry syllabus. Okay. Question number 15 then. The diagram represents a satellite communication link between 2 points on Earth. The distances between the transmitting station, the satellite, and the receiving station are shown. The frequency of the waves used for the link can be taken as 1.5 times 10 to the 10 hertz, and the speed of light is 3 times 10 to the 8 meters per second. What type of wave is used in such a link, and what is the time delay between a signal being transmitted and then being received at the receiving station? So, first of all, in terms of transmitting, we use microwaves. That is just a fact of how communication works. You can also figure it out from the frequency, since these are going to be lower frequency waves, waves with frequencies on the lower spectrum of things. But anyway, we know we don't use ultraviolet to transmit waves. It's going to be one of the first answer options then. Now, in terms of the time delay, this is just us using the equation speed is equal to distance over time. So 3 times 10 to the 8 is equal to the total distance, which is 90,000 kilometers, or 9 times 10 to the 90 times 10 to the power of 6 meters, because there's 1,000 kilometers per meter over time. So overall we have 90 times 10 to the power of 6 over 3 times 10 to the power of 8 is equal to the time, which is going to be 30 times 10 to the minus 2, which is equal to 0.3 seconds. So therefore the correct answer option, question number 15, is going to be D. We're using microwaves and the time delay is 0.3 seconds. I guess the mistake you could make here is thinking you only need to use this distance, but it's asking for the time delay from the transmitting station to the receiving station. Okay, so now question number 16. The diagram shows a quadrilateral PQRS. Given that tan theta is 4/3, what is the area of the overall quadrilateral PQRS? So from SOHCAHTOA, tan is opposite over adjacent. So the ratio of Q, let's call this X, to PX is 4:3. However, we can clearly see that the shape QXSR is a rectangle, i.e. QX is longer than QR. So if we double the ratio 4/3, we get 8/6, which makes more sense given the context of the shape we're working with. So if we go over this assumption, the area of this rectangle here is 40, and the area of this triangle here is half times 6 times 8. That's just the formula for area of a triangle, half base times height, which is just 3 times 8, which is 24. 40 plus 24 is going to be equal to 64 centimeters squared, which is the correct answer in this case. Again, we could assume other things, but given the answer options we have, this answer makes sense and time is precious, so we go with it. Okay. Question number 17 then. Which of the following statements could describe the result of a single mutation of a gene coding for protease enzyme in a fertilized human egg cell? Number 1. A new allele is formed, coding for protease enzyme that works more efficiently. That's possible. 2. Same thing but less efficiently. Also possible. 3. Non-functional protein that has no effect on the cell. Also possible. That's just a missense mutation. 4. A new allele is formed coding for non-functional protein that has a negative effect on the cell. That's also possible. So all of the statements are correct, and the correct answer option is G. So when you have a mutation, the allele is going to change and the protein is going to change. And that protein can be pretty much anything. You can have one that's better, worse, does nothing, or is completely harmful. But yeah, okay. So now question number 18. What volume of a 0.1 moles per decimeter cubed solution of NaOH is needed to neutralize 30 centimeters cubed of a 0.2 mole per decimeter cubed aqueous solution of a diprotic acid? So the ratio you're going to need is 2 NaOH to 1. Since it's a diprotic acid, you need to balance it out. However, the other thing you need to remember is the concentration of NaOH is also half. So we're going to need to account for this as well. So what we can say is 30 times 2 is equal to 60. That accounts for the fact it's a diprotic acid. And now we need to account for the fact that NaOH is half as concentrated as the diprotic acid. So we need to do 60 times 2, which is equal to 120 cm cubed, which is answer option E. Instead of actually doing the calculations, I've done this by proportion. We need 2 moles of our alkali to neutralize the diprotic acid, so we need double the volume. And also the alkali is half as concentrated, so again, we need double the volume. So by proportion, the answer is going to be 4 times 30, which is 120 centimeters cubed. Subscribe to my channel for part 3 of this 2016 BMAT Section 2 walkthrough, and if you guys are sitting with BMAT this year, check out sigmamed.co.uk. Honestly, the course is an amazing investment into your BMAT preparation. It's only £30 and contains all the knowledge that I use to score an 8.6 in BMAT Section 2. Thank you for watching.